Hello, this is Shala Farzana, and I'm presenting our paper titled Are Interaction Pattern Helpful for Task-Agnostic Dementia Detection and Empirical Exploration? Let's first talk about what is dementia and how it is related to cognitive impairment. So, dementia is a medical condition exhibiting different kind of cognitive deficits like memory impairment, language impairment, or mood or behavioral changes, and so on. In today's world, insurgence of dementia is a global issue related to aging, and according to World Alzheimer Report 2021, it is the seventh leading cause of mortality globally. So there are many types of dementia and different stages of dementia. So the early stage is called mild cognitive impairment when daily activities is not that compromised, but when it goes and mature, it is diagnosed as dementia. So as cognitive impairment and language impairment is a key uh, symptom of dementia. So there has been some standardized test or cognitive test and language test that has been administered by clinicians, and it has been used by the researchers to develop some automated dementia detection strategy to gain some speech-based biomarkers, and it has been performed with quite a high accuracy. But most of the studies rely on task-specific task-specific data set, and we believe that machine learning model should be trained on a generalizable data set that can work on different cognitive tasks. So that's why we are actually aiming for task-agnostic dementia detection framework. So first of all, we have worked with two different cognitive tasks from dementia detection dataset, and we have analyzed it from conversational viewpoint and collected the dialogue act tags from these conversations. And we have also developed a dialog tagging model that can automate this annotation process. And finally, with these dialog annotation tags, we have generated some content-free features that can be utilized for task-agnostic dementia detection. So to talk more about your approach. First, using the transcripts, conversational transcripts we have from both of the cognitive tasks, we have collected some code level annotations from the dialogue act tags for each utterances in the transcripts. And also we have trained on those gold annotated annotations, our own neural based model for annotating the process and automating the annotations. So after collecting those annotations, we have generated the content free features that has been utilized for dementia detection model. So first of all, our data annotation process, it is, we have used our previously proposed data annotation scheme, which has been used to annotate the predictive description task from the dementia bank data set in our previous work, and we have used that and annotation scheme and normalized and adapted it for annotating verbal fluency task, which is another part of the dementia detection dataset. And here we can see in this table different DA tags and its frequency across two different cognitive tasks is a quite imbalanced distribution. In our dialog act tagger, to automate the annotation process, we have proposed a automated tagger which has used the sentence level embedding, linguistic parts of speech features, and also the speaker tag, and all of those have concatenated and you processed by a tense layer, and then final layer has been trained to generate the DA tags. These features we have been used for current and the previous utterances. And finally, we have generated some content-free features, which include the Ngram-based features, which capture the local interaction pattern. Turn-taking features captures the conversation flow, and the ratio-based features actually capture the global interaction pattern based on question answer ratio, and we have trained a random forest-based classifier using these hyperparameters. For our data set, as we said, like we use two different cognitive tasks from dementia banquet corpus. One is picture description task and one is verbal fluency task. So here we can see some sample transcripts. We have normalized the DA tags for both of these, facilitate both of these cognitive tasks, and trained our own DA tagger with this. So for the evaluation purpose, we have used tenfold cross validation, and we have generated the micro average F1 score. In this table, we can see that our context-based condition, like where we use current and previous utterance embedding and speaker information, it has performed the best in our all the different tasks, especially in the joint task. We have got 5% boost compared to our baseline model, which is just using the current utterance. And if we dig a little bit better, we can see in certain DA tags like instruction, acknowledgement, different type of answers, these DA tags using the speaker tag and the previous utterance context, it has give us some performance boost. And also for the dementia detection task, when we use all the content-free features together, it has given us the best performance in accuracy and also in F1 score across the different diagnostic classes. So we can see that we have using these content-free features, it has given us promising result in a detection task, but however we have some shortcomings, like the data set is not that balanced. So we would like to extend our work to create a more balanced data set, and also experiment with the features generated with the silver DA tags, and we will experiment like how these results actually hold for those kind of extended task agnostic data set. And also we believe that these findings can help guide the design and dialogue agents for virtual interviewing in the cognitive health screening domain. So that's all. Thanks for your time. Yeah, if you have any question, I would happy to answer.